So thank you, everyone. My name is Emil Forslund, and I'm from Sweden originally, but since 2015, I've lived in California, working on a open source project called Speedment. So that's what I'm going to talk to you about today. So basically, Speedment is a open source tool for Java developers that helps you to get a Java stream over the contents of a database. So when you add filters to the stream, we translate it into SQL and sends it to the database, and you can stop having to bother about SQL at all. So I'm going to show you some examples of how it is in practice and talk a little bit of how it works. If I can get it to switch. There we go. So most of this presentation is based on an article that my colleague Per wrote in the Oracle Java magazine last year. And it's called Using Java 8 Stream Syntax Instead of SQL. So why do we use SQL at all? Well, SQL is something called a declarative language. You tell the database what you want to have done. You don't tell it how to do it. And then it's up to the database to figure out how most efficiently to perform the query that you are specifying. So for an example, if you say select where you don't tell it, I want you to use this index and I want you to look it up using this method. What you tell it is, I want this data, I want this subset of data. And then the database figures out the most efficient way to perform that. So that's the reason why we have SQL, to abstract away the way it works from the way we have to express it. The problem is when you mix this with Java, because Java is a type-safe language. It's a language that you always have the strength of the language to help you along the way. So when you start using SQL inside of Java, you lose the type safety, and you lose most of the performance that you wanted SQL in the first place to solve. So this is what I'm going to talk a little bit in this presentation. So throughout this presentation, I'm going to use a few examples. All the examples are based on the Sakila database. It's an open database for MySQL. That's basically a movie rental store. So whenever you hear me talk about films and actors and ratings and so on, it's because I'm basing it on this open source database. So let's consider this simple SQL query here. Select star from film where rating equals PG-13. This actually resembles a lot a stream. Film stream filter where film rating equals PG-13. So why shouldn't you be able to write like that? The difference is that in both cases you are using declarative constructs. You're writing what you want to do rather than how to do it. And but in the latter case, you actually have type safety and you have the strength of the IDE to help you as you develop. There is a lot of similarities between SQL and streams. So if we take a look at the different wording, we can see that they actually took a lot of inspiration from SQL when they wrote the Stream API. So we have count, we have limits, we have distinct, and so on and so on. Some differences exist as well, but you can kind of see the mapping in between. Both are created so that you can express what data you want in a way, and you don't have to think about how to get it. So the reason why we created Speedment and open sourced it in 2015 is because when you're creating a database application and you want to, it usually takes hours to get it up and running. Even if you're using an ORM that's supposed to be there to help you along the way, if there's a lot of configuration that needs to be done, or you have to write a lot of boilerplate code, or you have to perfectly match an existing database using annotations and get the exact same structure as you have in the database. And this, it adds a lot of time on developing database applications. The next thing is that a lot of the code isn't really there to help your program. It's code that's there to help communicate with the ORM. So it's code that's just bridging between your world as a developer and the ORM, how they expect the code to be written. And often you end up mixing SQL and Java anyway. You can't really express that kind of select that you wanted to do, so you have to kind of inline it using SQL code. And then you lose the type safety, and you have to run the application to actually see that something is wrong. You can't get a compile time check. And a lot of ORMs are really slow. You have to spend a lot of time optimizing it and figure out the bottlenecks of it because it's not a clear mapping. So with Speedment, we wanted it to be pure Java. first off. No special APIs, it's just a stream API, and it's 100% Java, so you don't have to mix in any scripting language or anything like that. It's just the same APIs as you're used to. You have full type safety. You should see in your IDE if you have done something wrong. You don't have to run the application to try it. If you're trying to use a string where it's supposed to be an int, it should fail. It should be a compile time failure, and you don't have to run the application to see that. We also wanted to make use of the features of the streams, like lazy evaluation, that the stream can actually start pulling in data and don't have to look at the entire data set at one time. So we wanted to use that and make it blend into the way it works. And we wanted it to have a nice business-friendly license. So we open sourced it under Apache 2 so that people can use it even if they are an enterprise company and have to care about patents and so on. Currently, since 2015, it should be updated to 2018 there, we are the third largest Java ORM that's not Android based. There's a lot of Android ORMs out there, but we are the third largest like desktop Java ORM. So these are the countries where we have users. We have a few thousand users currently that's have interacted with us in some way on GitHub. Most of them are from China or the US, but we are trying to grow our Swedish community here. So I hope that you'll check it out after the presentation. So how does it work? Well, Speedment, when you write a stream and you terminate the operation, it connects to the database in the background, starts fetching results, and then make it so that results come back into the stream without you having to think about it. It waits with querying the database until data is actually consumed. So if you're doing some kind of optimization that avoids the entire stream having to be materialized, it's never going to go to the database anyway. Also, if you do something that could be optimized away or optimized in a better way later in the stream, it will use that in the lazy evaluation. So the pipeline is analyzed before it's sent so that to make sure that you don't have to send more data than absolutely necessary. And operations like filter and sorted and so on can be moved into different places in the stream depending on where it's most performant to perform it. So a filter, for example, can drastically reduce the amount of data that's being sent over the network. So we want to put that first often, if it's possible to do so without breaking the results. So take these two examples here where we had the films stream, .filter, film rating equals PG-13. At first, you could think that these are the equivalents. They are doing the same thing, right? Turns out that's not the case because in the top case, you have case sensitivity. In the bottom case, SQL doesn't specify it. Most of the time, it's going to be case insensitive. So these are not equivalent, and this is one of the causes of many bugs. Instead, you would have to, in MySQL, write something like this, collate UTF-8 bin. But it depends on the collation of the database. You might have to write something else even in MySQL. And if you're using Postgres, you have to rewrite your entire query. So this is one of the examples when SQL isn't a perfect match for Java. Next thing is you don't want to write select star most of the case, because if you add a column in the database, you won't see that in your code that something is wrong until you run it and it breaks. So you typically want to specify exactly the columns that you are requesting so that you have a one-to-one mapping between your application and a database. But that ends up having to write a lot of stuff, and you have to put the underscores in the right place, and you have to look up the database structure before you write your query, and it's a lot of extra time. Next thing is, in the bottom case, you don't really specify any order. Usually it's the primary key order of the database, but what if you wanted it in some different order? You have to wrap it into some query to order it by and keep the consistency of the case sensitivity and so on, and it starts to be quite a mess, while in the stream it's just one single line extra. The beautiful thing of this, one thing more, getting the connection to the database. Unless you're using an ORM, this is one of the typical pieces of code that most people just copy from the web over and over and over again. And every time you have to copy something from the web, you have the risk of introducing errors. The code should be so minimal that you can write it on the top of your head without having to look it up. So take a look at the lazy evaluation here. We have a films collection of some kind. We stream over it. We filter out the films with a certain rating, and then we limit it to 10. And then we do something with it. Now the question is, how many rows are retrieved from the database? Well, streams work backwards. So they don't do anything until you come to the terminating operation, the last operation. That's when you start pulling in things. So then it will go back up and start requesting items. So it will request exactly 10 items or less if there's less rows in the database that matches the filter. So the final query will never return more than 10 results. Even though you as a programmer don't specify anything regarding database here. You could take the same stream and run it on a regular Java collection and you would get appropriate results. It's abstracted away from you as a developer. Next thing is parallelism. I mean, today most computers have multiple cores, while SQL is a language that's not really written to be able to express that. Of course, the database can be parallelized underneath the hood, but as soon as you send the data over the wire, you suddenly have a serial application. So how do you get advantage of your multiple cores on the server software that you have? Well, Java has something called parallel, and with Speedment, all our streams are completely concurrent. So we will actually start multiple connections, try and fetch data and process it in parallel as soon as we get it. So a little bit about this query here. First off, this is no magic interface. This is the regular Java util stream. This is the same interface that's available in the Java package. The nice thing is that when they developed the new Java 8 APIs, they made it interfaces. So you can actually switch out the entire implementation underneath without it affecting the client application. So that's exactly what we've done. We have implemented our own streams using the exact same interface as Java has. Next thing is you have full type safety. We will generate all these classes, all these entities, all these enum constants and so on based on your database. So you don't have to write any boilerplate code. You just get it. And if you update something in the database, you just regenerate and now you have updated code and you will see a compile time error if something breaks. It is lazy, so that in this case where you do a count operation at the end, it will only load one single numeric value from the database. It won't pull down any rows, it won't pull out any additional data, just one single value. And this is how the query on the backside will look on if you're using a MySQL database. And the beautiful thing here is that if you just switch out the database back to a Postgres database, you'll get this without having to change anything in the code. So you don't have to bother about what kind of database you're running, how their particular SQL dialect looks. You don't have to bother about, keeping a perfect match between how you name your tables with how the database names it. You just have to write it and you'll see a compile time error if something breaks. So the pipeline in this case that you saw before, this stream operation is something like this. This is what Speedment sees. We see a terminating operation, 2 filters, and some kind of source. The source is created by Speedment. It's our stream implementation. So by default, we will have a source that matches something like select star from film, except that it also specifies all the columns. Could somebody open there? I think somebody wants to get in. The door might be locked. Yeah. So the source is something like this, a regular SQL query that will just pull everything from the table down into the clients. And when you terminate the operation, we will start looking at the different operations, the pipeline that we have before us, to see what parts we can merge into the source. So in this case, we have a filter operation. So we will merge that into, because this is a filter we can recognize. We know all the types in here. It's Speedment generated types. It's a Speedment generated predicates. We will recognize it and we will merge it into the query. Then we'll look with the next operation in the pipeline and see that this is also Speedment generated predicates. So we can merge that as well into the source. And then finally, we can see that, well, we don't really have to create a stream at all, because all that the user sees, the only thing that's returned from this entire expression is a long value. So we can avoid creating a stream in the first place and just return a long value that we get directly from the database. So this is the final query that's being sent. So is this legit? Are you allowed to do this kind of manipulations of streams? Well, yes. If you look in the documentation of the Stream API, this is Java 9, but it's the same in Java 10, you will see that they actually specify that you can never expect a particular operation to be executed. You can only expect that the results of it will be as documented. So if you do a peek, for an example, it might not get executed on all implementations. Or if you use a find first, then it says that only one value is going to be returned. So some of the preceding operations might not be performed as long as the result is the same. So they actually took, space for this when they created the API. They made it so that all the functional interfaces are clearly specified. They should not have any side effects. If you implement a functional interface with side effects, it might have different behaviors depending on the implementation. So the generated code, I said quickly that Speedman generates code. This is pretty much what it will create for a table called film. First, we will have a entity that is we generate. We always create interfaces for everything because we have seen when we have implemented Speedman how useful it is to have the ability to change the implementation of an interface. So we always generate both an interface and a default implementation. And we also create an internal package called generated for every. So the general use case for Speedman is that everything that's in the generated package, we will regenerate each time you run Speedman. So this code will, it will not be persisted. It will be recreated each time. So don't put anything valuable in there. These, however, have hash codes. So if you modify anything in these non-generated files, we will keep it. So we will not regenerate it. So with Speedman, you can change out the implementations. You can write your own code in here, add methods, and change the way they work. And it will not be overwritten with Speedman, but these ones will. So we encourage you to create your own implementations if you want something to work differently. How difficult is it to set up Speedman? It's actually 2 lines of code. We will generate a builder pattern for you based on your database. You just create the builder. If you have a password for your database, you have to specify that, and then you build. And now we have an application that's kind of the container for all the streams and all the runtime logic of Speedman. And then you can retrieve different managers that you use to access different tables from it by just writing get or throw film manager. So this is the general pattern. We don't use any static variables. Storing things in static variables will break stuff if you're using an app server. Everything is contained in this single instance. So these classes are generated based on your database. I see that there has come some kind of Sakila application app. It's a space missing there. We use builders so that you can configure everything exactly as you want it. If you have a different, connection URL, you can specify that. If you have a different user, if you want to add modules, remove modules, and so on, you can do that. We generate managers for each table. And if you want to integrate it with like a framework like Spring or Java EE, it works really well with the bean patterns. So how many here are using Spring, by the way? 3, 4 people. There are more in the US. Spring is great, by the way. Basically, you create one single file that's the configuration, and it has a bean annotated method that returns the application, the Speedman application. And then you can use a configuration file to specify the usernames and passwords and so on. The managers are bean annotated as well. You just add this single line method, and then you can use the Spring internal autowire method to get your managers in the right place. So this is how it will look in a controller. You just autowire in the manager, and then you can write a REST API like this. Just put the line we had before, this films at the beginning of the file, and then you can return a stream like this. Sorry, if you wanted to look at it. So yeah, the REST API you just saw will correspond to basically this SQL statement. So it just returns all the films for a particular page, and the user can specify which page by just adding a path variable. if you don't want to put up all those configurations, then we have an open source plugin called the Speedment Spring plugin that generates all the beans, all the configuration files, and so on. So you just plug that in, and then you have a Spring compatible environment. Speedment is completely modular. So all the components of Speedment can be turned off by just removing that dependency, and you can add your own implementations of them. We encourage people to modify the behavior. If you want a class generated to look different, just plug in a different generator, and you can specify exactly how you want that class to look. So some people actually just use Speedment for the code generation. They disable all of the auto-generated classes, and then they just use it to specify their own generated files based on a database. To get started, if you're interested in trying it out, we've created a little web service that basically generates a main file and a POM file for you. So you can just specify which database you have, if you want any of our official plugins, if you want in-memory acceleration, that we'll talk about in a minute, and so on. And you will get all the configuration files you need. So that's a great way to, if you want just to get an application up and running quickly. What the application does is that it adds a plugin to your POM file if you're using Maven that does all the code generation and so on. So this plugin will generate code. If you don't want it to run, you can just remove that plugin and you will have your static code forever. We also have, so it generates based on a database. We also have one single dependency that you can add. The dependency is something called a bill of material, something that Spring uses a lot. So basically, this is a single POM file, and then it will in itself have dependencies on all the different modules of Speedment. All of this is only our own code, so we don't pull in any third-party dependencies. It's only Speedment dependencies that you get by this. So it's great if you are in an existing application environment and you don't want to put in anything that can break a dependency. So everything is self-contained in this. We have a graphical tool that comes with the Maven plugin. So as soon as you have a POM file with this plugin in it, you have Speedment installed. You don't have to install an additional software. You can just write mvn speedment:tool, and you'll get a graphical tool written in Java that you can use to connect to the database, configure everything, and so on. So it's really easy to get started with. So the process of using Speedment is that once you have a Maven file, a POM file with the Speedment dependency and plugin, you can just launch the tool with this command and use it to generate code. Using the default settings, it's just pressing one single button and it will generate. Then you can write your Java code based on using these generated classes. You'll have full type safety. You'll see immediately if you do something wrong. And then you can run your application and iterate. So the idea is to have like the iteration of writing a database application down to minutes. You just launch the GUI, generate code, write some code, try it out, change some parameters in the GUI, and so on. You can work interactively with this. So to summarize the slide part of this presentation, Speedment allows you to get a Java 8 stream connected to a database. You have full type safety in everything you write. The streams are lazy, so you don't pull in any more data than you're actually using, and supports full parallelization. So if you have multiple cores on your computer, you can really take advantage of it. And if you want to contribute, we're open source, so feel free to join us. Now I'm going to show you some live coding, if the demo gods are with me. So, like this. So, do you see everything? Sadly, this is JShell, by the way. It's came with Java 9, but it's basically a rep loop or a interactive terminal that you can use with Java 9 and up. So the problem with JShell is that all the code happens down there. There's no way of, beginning from the top. So you'll have to live with it. Or I can perhaps, I'm smart. So maybe now it's a little bit easier to see. So I'm going to show you some examples. So let's reset this environment just so I don't have any previous state, no previous variables allocated. Let's get started with Speedment. So I'm going to just import some things. It's the generated code that I've created in this application. And then I'm going to use the Java 10 var to create a Speedment application. So I just write start Speedment. And Speedment launches. And it's now connected to the database. So I can write var films equals app get or throw and just take the film manager.class. And you can see that I have help from the A shell. Since everything is type safe, it will fill in the things I'm using for me. Next, I can write films.stream.count. And it says that there is 1,000 films in the database, and I've configured it so it also prints out all of the SQL commands that's being generated. So here I have written a database application. You don't have to be more than 3 lines. Next, if we want to do something a little bit more fun with this, we can say films.stream, and then we can add a filter. We can say film.rating, like I had in my example, dot equal rating, missing a parenthesis, rating dot, and I can see which values are available. This is great because usually you don't remember maybe if it was specified as NC_17 in the database, or if it was NC17 and so on. So in this way, you will get help with getting every constant written perfectly. And I can say PG13 and let's count the stream. And you'll see a little bit more advanced SQL query, and there are 223 films in the database. Next, if we want to do something, we can add a filter more and say filter film, and we can ask it what columns are available. These ones. So we can say, for example, length. I want to see movies that are less than 60 minutes. And then I can count those. And now we're down on quite a reasonable amount, so we can instead choose to do a for each system out print line. And it will print out all of the movies. Or I can add a map operation and get only the titles, so it's easier to see. And just say film.title. And now I have a list of all the films in the database. This is the kind of power you get by being able to tab complete and just write your database application based on the structure of the database. So how did I get to this point? There was a lot of magic happening here in the beginning. So I'm going to take a minute and just show you from complete scratch. Say that I have nothing installed on my computer and I want to use Speedment with the database. We can close this down. I'll go to the Speedment website and use the initializer. And this will open up this. It's a graphical tool. You can just configure what kind of database I have. I have a MariaDB database. I want to use a little bit more recent UDBC drivers. I'm going to switch to that. I want to use Java 10. I want to enable all of the plugins. And I want in-memory acceleration that we'll get to in a minute. And we can call this com Speedment example and Malmö jog. Like this. So we can just... So let's just disable in-memory acceleration for now, and we can talk about it in a minute. We can just copy-paste that. Go here, go to Malmö jog. Then we can delete all this. So now I have a blank project. Just create a pom.xml file. Add the generated code. And then we can run Maven Speedment tool. So nothing is specially installed. This is just running the plugin that we just added to our POM file. Let's see what the problem is here. This is what it looks like, basically. So the Speedment tool is executed through a Maven goal. On the left side, you'll see all the tables of the database. On the right side, you can configure the individual settings, or you can just write generate, and it will generate code based on that. If you want to change something, like change the naming convention of a table, you can just press that and you can deselect the auto value and set like movie instead. And it will generate code based on that instead. So let's switch it back to default. So that's basically how we work with the graphical tool. The generated code will appear in the same project. If you want to change anything in the generated code, make your changes in these non-generated packages, or that's not named .generated. They are basically stubs by default, and these will only be regenerated if the hash code matches the stored settings. So if I add something here, that file will be persistent. The generated package, however, contains all of the implementation, and this is regenerated each time. And yeah, the application looks something like this. I think I renamed it movie, so this no longer work. So if you change something, you'll get a compile time error immediately that shows you that. So yeah, any questions so far on this part? Yeah. Yes, we have something called a join module. So if I want to get a join, I could just write app.getOrThrow join component, because joins are not really compatible with the stream interface by default. So we'll have to use this and use a SQL-like syntax. You say from and then on and so on. And then you'll get a stream based on the join table. And it will, in practice, be a stream of tuples. So that's how it works. So we had a lot of struggle kind of figuring out how to express streams using the Stream API, because we wanted it to be completely using streams. But as you might know, a stream can't really be, it only has one type. It can't have multiple generic types. So using a tuple was the easiest way. Yes. Any more? Yes. Not currently. It is pulling in the entire entity and then selecting out the title. But it will know that if you put something else after the type operation, it will be smart enough to be able to put it before the mapping operation. So it can do some optimization still, but it will still always pull the entire entity as of now. Any more questions? Hmm? Yeah, I mean, the domain knowledge you'll see in the generated code, so you don't really have to know anything else than the URL and the schema. Yeah, you need to know, but you will see in your IDE the generated tables. So you will see what tables are available, and you can probably figure out the rest from there. But yeah, that's correct. Yeah, thank you. It's yeah. If you have the option of adding a view in a database, it's always better, because then we will also generate an entity based on that view, so you will have a real entity from it. So if you can change your database structure or add a view like that, that's always better. Then we will only retrieve like a single stream over that entity, and the database can figure out the joining structure. But if you can't change your database because the database is a legacy database or something that it's not your team that manage, then you can do the joins on the client side and use the join component. And we will do our best to try and translate that into SQL. So we do support multi-joins, and we do support most of the joining operations, but joining is like a jungle of different things that can happen. So we support the most common kind of joins that you can do. So always the best thing, the most performant way of using joins with this is to create a view and allow the database to figure out how to do the join. Does that answer your question? Yeah. No, we don't have any option of adding custom SQL. However, we don't claim sole ownership of the database. So you can always send a SQL query using either another ORM or using a regular JDBC connection. So that works. And you could use like our SQL adapter to get one of our entities back from it. But we don't offer an option of sending SQL to the database. That's only something that our streams itself can do. So yeah, Usually, if you have a complex where clause, you can express it with streams. I mean, the predicate interface in Java has an and an or method, and we will recognize those and introduce them into the SQL query. So unless it's something really kind of weird, we should be able to optimize it. We support likes. But if it's like a really complex like with a regular expression or something like that, we don't support it. Yeah, but the most common, yeah, no. So what will happen if you try to do it, if you do a lambda and you do something like that we can't recognize, is that we will pull as much as possible, as little as possible, but to still satisfy the preconditions of that, and then we'll handle the rest on the client side. So the query will still work, and if your database is quite reasonable size, it should be okay. But that's basically always our fallback case is pull as little as possible, but it still satisfies the preconditions, and then handle the rest on the client side. Was it a no? So yeah, let's get back to the presentation. And so a little bit about, so far I've talked about the open source product. We also have a enterprise module for this, and it adds additional functionality. Basically, it has the stream, exactly the same APIs as the open source. You only add 2 lines of code, and suddenly your application is in-memory accelerated. So the first line is enabling the in-memory bundle. The next line is tell it to pull in data. And then it will build an in-memory view of your database and do all of the streaming in memory instead. So with this, you can get streams down to microseconds in performance. As a comparison, a normal Java stream over a collection is not this fast. The reason is that the normal collections store objects on heap, and it will add garbage collect cycles if you start coming up in millions or tens of millions of objects. The enterprise implementation of Speedment stores everything off heap, so you don't get any garbage collect issues, and you can get up to 1,000 times speed up compared to sending it to the database and back. So here's an example of the previous that you saw previously. It's an open source. Everything here is available open source. You just add an in-memory bundle that's an enterprise class, and you tell it to load data. And when this line is reached, it will start pulling in data in the background and then seamlessly use the in-memory view instead down here. And then you can tell it to reload, and you can tell it to clear the data and so on if you want to. So nothing has changed. And how does it become fast? First thing is that a lot of people talk about scale out when we talk about in-memory stuff. We choose to instead talk about scale up rather. If all the data is available on the same machine that's needing the data, it can be extremely fast compared to having to retrieve the data from somewhere else. So as soon as you scale out, you will have latency. You will have issue with sending data across nodes. We also store all of the data in JVM memory compared to on disk or something like that, and with emphasis on all the data. So instead of having to miss a cache and having to go to disk anyway, with the Speedment cache, everything is inside the JVM memory, so it's always fast. You can never have a cache miss. To avoid the garbage collect limitations, everything is stored off the heap, meaning that it's not collected by the garbage collection. You also have a much more, you can beforehand know exactly how much time a query can take because the garbage collect adds variance to the times. Just as an explanation of what I mean with off heap, if you join, the entire join operations will be performed off heap. No intermediate objects created on the heap. If you use aggregations, we will store all the intermediate values off the heap, meaning no garbage collect. And if you want to serialize something to JSON, we will perform the actual JSON serializations off heap. So all this is written with regular Java. There is no like native C++ mixed in or anything like that. It's Java code, but you can get the benefit of having extreme speed, and no matter how much data you put into it, as long as it fits into the physical RAM, you're okay. You have great concurrency. all of the Stream APIs are completely concurrent. So with this, you can actually use a 40+ core system and get full concurrency on all your operations. We have one customer that's using this on about 480 gigabytes of memory and 48 cores. So it really scales out well. We store everything in an extremely dense memory format compared to how it's stored on the heap, where there's a lot of space in between to kind of fit metadata and so on of the different objects. The Speedment memory format is extremely dense, meaning that if the row is 12 bytes large and you have 10 million rows, it will take up exactly 10 million times 12 bytes. And it will be extremely fast to iterate over that. Think like an array, except you can have hundreds of millions of rows. We support partial deserialization. So the thing you talked about previously, where you used the map operation and only looked at one particular column, we support that. So if you're using the Speedment Enterprise product, if you do a filter or a mapping operation on a particular column, only that column is retrieved from the off-heap memory and put onto the heap. And we have built-in indexes. So like a SQL database that uses trees or hash maps and so on to efficiently retrieve data based on your filters, we do the same thing, except we do it in memory instead. So we'll have extremely rapid lookup. We also have a built-in query planner, similar to a relational database. So even if your most efficient filter is not at first, we will recognize which filter is most efficiently in this case and move it up. So if data changes, we will, when you tell us to load a new view of the database, we will load it, so it's eventually consistent. You never have a half consistent view. You always have one, possibly a little bit old view of the database. We have background loading. So while your application is running and serving requests, we can start pulling in a new view in the background, and we'll only switch over once that view is complete. So we will have zero downtime. There is zero time in between where the data is not updated or so on. So if you're interested in this, you saw the in-memory acceleration button on the initializer. If you just enable that, you can get a 30-day free trial on our website, and you can try it out. Otherwise, you can just use the open source. You can contribute. We're happy to have you as users. So yes, I see that the pizza has arrived. So